Hi everybody, Scientific Sally here with Mad Science, and I am going to show you some really awesome experiments. What we're doing today is we're going to be talking about physical and chemical changes. In the science world, it's all about physical and chemical changes. Every time we mix something, we put something together, we want to know, did a physical change happen or did a chemical change happen? With physical changes, it's kind of a little easier to explain because let's say, have you guys ever gone to the hair salon and gotten a haircut? When you got a haircut, did you walk out of there looking like a puppy? No. Did you change into a gorilla? No. You're still you. The only difference is you now have shorter hair. Well, that's what a physical change is. It's a physical appearance that has changed. And a lot of people think that physical changes, they're boring. Those are boring experiments. Those aren't fun, but they actually are a lot of fun. I'm going to show you with a little bit of help from this special ice right here. This special ice right here is called dry ice. If you can tell, before I'm even touching the dry ice, I'm putting these on. These are gloves. Now, these aren't just any type of gloves that you wear during, the winter time. These are heavy-duty gloves. They're extra thick, and they're going to provide extra protection for me. The reason I need protection is because dry ice is very, very cold. Regular ice freezes at -0 degrees Celsius, and dry ice freezes at -79 degrees Celsius. So it is very, very, very cold. And right here, as we're outside, you can tell something else is happening to this. You see all that steam that's coming off of this? This is basically sublimation. We're going to talk about that a little bit later on. But I want you guys to be able to see when I blow on it, more of that gas starts to come out. Now, water, when we freeze water into ice, anybody know the molecular formula to that? It's called H2O, 2 hydrogens and 1 oxygen. Whenever it goes from an ice to water, it didn't change. It's still water. It's still 2 hydrogens and 1 oxygen. The only thing that changed was its appearance. That is a physical change. This is a physical change too. It's going from this solid to a gas, like you can see. Now, I can make this sublimate a lot faster. I can break it down into little pieces, and I can put it into something that's going to want to make it go a little faster, which is water. I just decided to go a little fancy and make it green, but it's still water. And in my bag right here, crushed dry ice, okay? No big deal, just crushed dry ice. And I'm going to put some of this crushed dry ice into this bottle. So now, as you can see, my dry ice is sublimating super, super fast. That water is so hot to the dry ice that it makes it want to sublimate really fast. But it is still carbon dioxide gas. I haven't changed anything. I haven't done anything chemically to it. The formula, the molecular formula is still the same. It is still carbon dioxide gas, CO2. That means carbon and 2 oxygens. And you can tell right here that I can even take it and taste it. Now, even though the solid form of carbon dioxide gas, dry ice, is dangerous, the gas form isn't dangerous. And you would know that because if you guys ever had any fizzy drinks, they basically put carbon dioxide gas in there. Those are carbonated beverages. So those carbonated beverages are able to go in a gas form. You're able to ingest them, but not in a solid form. So there's another way that I can even take this and change it even more into a physical change. Here I have another flask. And in this flask, I have red water. I just decided to get fancy again. And there's going to be one change I'm going to do. But before I do that, I'm going to put some dry ice in there, just so that you can see the difference. All right, here you go. No big deal, right? The same thing as that one, but I'm going to add something different. I'm going to add some soap solution to it. And we're going to see what happens. Oh, something happened there, didn't it? Well, now I have physically changed the appearance of the gas. Now I have trapped it into these bubbles. And if I take it and I pop it, you can see all the gas is escaping. But I haven't changed anything. It's still carbon dioxide. It's still sublimating. The only thing I've done is I've changed its appearance. So it can change. So I have made this dry ice physically change from a block of dry ice to a gas to bubbles. But it's all the same thing. That is an example of physical change. Okay, guys, another cool thing that I can show you that's a little different from these bubbles is to kind of just show you how dry ice gets trapped inside that bubble solution is I'm going to show you big bubbles. And the way I'm going to do that is in here, it's just a tube, and I have water, good old H2O, and I have some dry ice that I just finished putting in there. And then what I'm going to do is I'm going to cover it up, and all of the gas, carbon dioxide gas, is coming out of this tube right here, okay? And what I'm going to dip this tube into is this cup. And in this cup, I have bubble solution, just like the bubble solution that you buy in the stores. And I'm going to dip it right in here, let it go in there for a little bit. And you can see bubbles not only forming down here, but also bubbles forming from the end of my plastic tube. Same thing, physical change. It just looks really cool. One more time. And there we go. So chemical changes are a little different than physical changes. Chemical changes, you actually have chemical changes that happen at your home all the time. If you guys have ever cut open an apple and decided you only wanted half the apple, and you left the other half on the counter, what happens to that apple after a while? It starts to brown up. That's called oxidation, and that is a chemical reaction. It also happens with other things like bananas, and more importantly, whenever you leave something in the refrigerator for too long and it starts to smell, that's also a chemical reaction that's happening. And the smell, the really strong odor, is another sign that a chemical reaction has occurred. There's other ways to know that chemical reactions have happened. There's a color change, bubbles form, a gas is released, which is like bubbles form. There's a completely new substance that is formed. And then there's also if a temperature changes, like if it's an exothermic reaction. So we're going to actually go through all of those. So the first thing we're going to go through is a color change. So here I have some glassware. And when you look at it at first glance, you seem to think it's all water, right? It's not. In the science world, we learned a long time ago that if it looks like water, but you don't know, then don't treat it like it's water. So here, my water exhibit A and my water exhibit B, we're going to put them together and we're going to see what happens. Because when you put water on top of water, what happens? Nothing. You get more water, right? So let's take this glass right here and let's put it right over in here. Whoa. What just happened? It turned to another color. Water never does that unless I put some Kool-Aid in there or something. This is a chemical reaction. What I actually had in here, I did have water, but I had a base in there called sodium hydroxide. And sodium hydroxide is a base, like I just said, from a pH scale. And you find bases in your house too. Toothpaste, Windex cleaner, other household cleaners, those are all bases. And there's something called a pH scale. And that pH scale, it goes from 0 all the way to 14. And 7 is neutral, which is usually water. Anything from 1 to 6 is an acid. Anything from 7 to 14 is a base. So what I had in here was water, but something called phenolphthalein. And phenolphthalein is an indicator, and it lets me know whether something is an acid or it's a base. So here, when I put the sodium hydroxide in here, phenolphthalein said, well, this is a base, and it changed to this beautiful, beautiful color. Now, in here, again, exhibit C looks like water, but it is not water. It is vinegar. I know that because as I'm wafting it, I can smell it, and it smells very, very familiar. And what I have in here, and this is an acid, okay? Pickle juice, that's an acid. Orange juice, that's an acid. Lemon juice, acid again. And what I'm going to do is I'm going to put this in here. So we're going to see what happens. Oh, there we go. Ooh, let's hope I have enough. Oh, are you seeing what I'm seeing? Are you seeing? Here it goes. There it goes. I think I might have enough. So right here, in the presence, phenolphthalein, in the presence of an acid, like vinegar, what it does is it changes back into a clear color. So this is obviously a chemical change. I have chemically changed these ingredients. I've chemically changed this one to make it go back into a clear liquid. That is one reason that it's a chemical change, a color change. All right, so we just saw a chemical change with color. So the other type of chemical change, or another sign of a chemical change, is when a new substance is created. And the best way for me to show you that is with this. Pretty simple, right? Piece of paper. Now, I can't show you a really easy physical change with this piece of paper. If I just grab it and tear it up. Still paper, right? It just looks a little different, torn, edges, but it's still paper. What I'm going to do to this paper now is I'm going to make it go through a chemical change. And the way I'm going to do that is by using fire. And do we ever play with fire? No. I went to many years of mad science school to learn how to use one of these things. So I am a trained professional. So what I'm going to do is I'm going to take this corner right here. All right. Lighting on fire, right? We knew this was going to happen. But what we maybe didn't know what was going to happen is the stuff that's forming there. The stuff that's forming there is something new. It's not paper. You can't build a paper airplane out of what's being left over. You can't do your homework out of this stuff right here. What is this gray stuff? It's ashes. Ashes are a new substance that this paper formed. It is something that's completely new. What else forms ashes whenever it burns? There they go. Wood. Whenever you have a campfire or something like that, it forms these ashes. And that is a completely new substance. That is another sign of a chemical change. And you also know that it's because it's something new because it rips all over the place and it's almost practically disappeared. Speaking of almost disappeared, I do have a special type of paper, another special type of paper that shows a chemical change too. It's actually already been changed. It's been chemically treated. This paper looks very much like tracing paper or tissue paper or something like that, but it isn't. This is a paper that is chemically treated to do something else, okay? What I have right here, or what I'm going to do is I'm going to take it and I'm going to scrunch it up just a little bit, all right? And then I'm going to take this lighter. And it completely disappears. Want to see it again? Of course you do. Everybody wants to see it again. So I'm going to take it, tear off a small piece, and again. Completely disappears. That is another type of chemical change. Another type of chemical change that we see is when a gas is being released. Now, you definitely see this if you guys bake. Whenever you guys bake a cake, do you want to eat a cake that's this big or a cake that's this big? You want to eat a cake that's this big. And the whole reason that happens is usually cake recipes will have something called baking soda inside the recipe. And what happens whenever you put that in the oven, a chemical reaction occurs and you have this new gas, carbon dioxide, which if you remember we talked about before, gets released and it puts holes in all the cake and it makes it air holes and it makes it all nice and squishy and big. Well, we can use that same type of science by doing a volcano. I know you guys have probably done a volcano at home. It's pretty popular. And if you guys heard me talk about it before, that acid-base reaction that we had going on with the color changing, here's another acid-base reaction that's going to happen. But not only is color going to happen, but it's not a color change reaction, but a gas is going to be released, and that's that carbon dioxide gas. So I have here my flask, which looks like a volcano, as you can see right here, and I'm going to put some baking soda right inside. And I would say that I'm probably going to put in about half a cup, I would say. Now, typically, you have this right here, just that base, the baking soda, and then you put the vinegar inside. And what you get is this just a lot of noise, a lot of sizzle, a lot of bubbles. I want to slow down that reaction a little bit. And if you guys remember in the dry ice, I slowed down that reaction from all that carbon dioxide coming out of the flask by putting in bubble solution. I'm going to do the same thing here. I'm going to put some bubble solution right inside. I'm going to give it a mix. I'm going to give it another mix. I'm definitely not being shy about it. And what this is going to do is it's going to cause my reaction to go by a little bit slower. And then what I'm going to put is I'm going to put some vinegar. And all I did with this vinegar is I just put some red food coloring inside. So I know this already looks like a volcano, but this is mad science. We like to go a little bigger. So I actually made a volcano, a big volcano. So we're going to put my flask right here, right behind this big volcano. And we're going to have it spill over, or we're going to see if it does. We're going to check out what happens. So let's do a little countdown of 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Explosion! Ooh. You see bubbles everywhere. All these bubbles, that's the carbon dioxide that formed. That's the carbon dioxide that's being released. That's what causes it to go all over the place. If I wouldn't have put that soap in there, you would have just seen bubbles come out, not a really specific color or anything like that. But the bubbles really help it go a lot slower. Pretty cool, huh? So chemical and physical changes are all over the chemistry world. They're especially important in chemistry because chemistry is all about the science behind mixing things together. So now that you know what physical changes and chemical changes look like, I think it's a really good idea to give you something that you can do at home, a home lab. So what you need is pretty easy, pretty simple. You just need a bowl. Doesn't have to be this big. It can just be a regular bowl. Cornstarch. If you don't know what cornstarch is, ask what your parents it is because usually you find it in the kitchen. And water, okay? And that's all you need. Oh, and food coloring if you want to make it a color. So what I'm going to make here goes by many different names. It's called a non-Newtonian fluid, but a lot of people call it quicksand. A lot of people call it magic mud. It's basically, I like it because it doesn't like to follow the rules. And sometimes I don't like to follow the rules. And what it does is it doesn't know whether to be a solid. It doesn't know whether to be a liquid. Depending on if you barely touch it or if you just let something settle in it, it acts like a liquid. And it just, you think it's, if you don't put any color in it, you think it's milk. But if you hit it hard with your hand, it acts like a solid. So what I'm going to do is in here, I'm going to make this a color. And I'm going to make it the color of mud. We're going to go ahead and call it magic mud. And mud is the color brown. Does anybody know what colors we need to mix together to get that brown color? Pretty much all of them. You just start mixing and all of them will eventually start to form. So let's see if I did a good job here. Let's mix these together. That looks like swamp. Let me go a little bit more. It's a little too greeny. Let's do some red. This will be the last one. And like I said, you don't have to make it a color. It can be white. If you want to make it a color, you can. This is messy. You definitely want to do it outside. It's a lot of fun, but it's definitely messy. And what you're going to do is you're going to put some cornstarch As you can see, I don't have a measurement, just however big your bowl is. Just put some in there, and then slowly but surely, you want to mix it with water. Don't put all the water in there. You just want to kind of let it pour and mix. Once you see that all the water is gone, then you want to pour again. And it starts to get harder and harder to mix. It almost seizes up on you. So you almost want to cut into it in order to get all that water to go away, to get well blended in the mixture. We're getting there. You can use your fingers if you want. I find it easier to use a utensil. There we go. Okay. So when you take a look at it, yeah, this is good. Okay. When you take a look at it and I move it around, it's like a liquid, right? If I take my hand, this one, these two, and I hit it hard, it acts like a solid. However, if I let my hand go into it, a liquid. You can even try to grab some and try to get it into a ball, and for a split second, and as you're feeling it, it acts like a solid. But if you look, it doesn't last very long. It reacts to force, and it reacts to how fast you can move it. But if you just let it go and let it act on its own, it'll act like a liquid. A lot of fun, really messy. It dries up after a while, but it's pretty easy cleanup. All you have to do is just put more water in it, and it's done. Another cool thing that you can do with it is that you can drop things like balls or rocks in it so that you can see them hit like a solid, but then as it stays there, it gets covered up like a liquid. It's a really fun experiment to do at home. Okay, guys, so now that I've showed you 3 different ways that you can tell whether something is a chemical change, this is my last one. This is going to be a temperature change reaction. It's going to be an exothermic reaction. Inside this boiling flask, I have 35% hydrogen peroxide, which in the molecular formula for that is H2O2. Very close to H2O. And there's a reason why I'm telling you that. Because at the end of the reaction, we're going to end up with oxygen steam that comes out. One of the new substances that comes out is this steam. So right here inside this little pill bottle, I have something else called potassium iodide. And this potassium iodide reacts with this hydrogen peroxide. In order to get it to, again, show you a little bit better and it's not just the steam coming out, I'm going to put bubble solution. As you can tell, I've been using this detergent, this bubble solution, a lot. So I'm going to put some right in here. And the other thing I'm going to do is I'm going to make it a color. So I'm going to make it blue for you to see it a little bit better. And I'm going to be pretty... I'm going to put a lot of blue in there so you can really see it. And I'm going to give it a little mix. Then what I'm going to do is I'm going to put on my safety goggles. I want to make sure and be safe at all times. And I'm going to put on my gloves to make sure that I'm protecting myself. All right? And just like we did with the Volcano, we're going to do a little countdown again. Put this in my pocket. All right, let's give this a little shake again. And we'll do from 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Woo! All right. As you can tell, you have all this stuff right here. As you can tell, we have all of this toothpaste that just came out. This experiment's called elephant toothpaste. And if you're able to see really, really close, there's all this steam that's coming out. And all that steam is that oxygen gas. Now, I don't know if you're able to hear it, but you can also hear it sizzle. If I were to touch this with my bare hands, it would burn me. So that's why we need to be very, very careful, and that's why we're wearing the gloves to make sure that we're being safe at all times. But this is another chemical reaction. I didn't start out with hot or heated experiments or liquids, but I ended up with a very, very hot reaction. It's pretty cool, right? All right, guys, I hope you had a wonderful time watching this. I know I had a wonderful time doing it. I hope that you ended up liking science a little bit more right now before you started watching, and I hope that you realize that no matter where you are, no matter where you go, there's always science somewhere around you. Thank you so much to Discovery Green for allowing me to do this here today. It was a beautiful day. It was a wonderful day, and you guys have an awesome, awesome day. Stay scientific.
Your well-being is important to all of us here at Discovery Green. We're relying on each other to stay healthy and strong, but we still need to share cultural experiences. The park and its online programming can help connect you with artists and musicians to help relieve the stress of these times while practicing safe distancing. If you can, please donate $30 to support this source of health and happiness for our community. You can give by text to Rediscover to 41444 or log on to discoverygreen.com/donate. Thank you.